might you integrate the teaching of programming with other aspects of the primary curriculum? Although it is a common assumption to categorise the majority of today's children as digital natives due to their frequent interactions with digital media, Resnick et al. States that it would be a mistake to conclude that they are completely fluent in new technologies. In fact, many children are unable to design their own games or simulations despite being able to text, email and stream the web. In order to develop their technological fluency, it is imperative that they receive a range of opportunities where they can develop their knowledge and understanding of programming in meaningful contexts. Pierce identifies a problem that has been found with the teaching of programming, in that it is being taught as a standalone subject isolated from other subjects and children's interests. This prevents children from making connections with programming and real-life situations. This shallow teaching of programming has led to children having more difficulty writing code rather than reading it, as pointed out by Lister. So how can we prevent this from continuing? Well, it is first helpful to examine the different aspects of programming and see how these can be supported by other subjects in the curriculum. Let's first look at algorithms. The computing curriculum states that Key Stage 2 children need to use logical reasoning to explain how some simple algorithms work and to detect and correct errors in algorithms and programs. Algorithms are a set of simple instructions or a set of rules that are followed to carry out a task. This can be any task, so immediately you are given some freedom to implement this into other subjects such as science. In order to work scientifically, children need to be able to plan experiments where clear and concise instructions are paramount. It can also be useful to link algorithms with scientific flowcharts to do with classification, emphasizing on the yes and no element. Another subject that can link in with algorithms is literacy, as children need to be exposed to a range of different writing styles such as non-fiction. Philip Bage demonstrates a lesson using algorithms where children work together to give clear and concise instructions to make a sandwich, which can easily be used to link into non-fiction writing lessons. By incorporating the scientific or literacy element to the teaching of algorithms, children are able to make connections between how algorithms are useful in the real world, thus providing them with that meaningful context. Furthermore, there is also a lot of links made between programming and mathematics. For instance, the concept of variables is one that overlaps between the two subjects. Variables are the storing of information. In regards to programming, this may include the score of the game, the timer, or the number of cars in the car park. This works in a similar way to algebra, which children are introduced to in years 5 and 6. By creating their own game using Scratch, like the one you can see here, children can experiment with different variables, such as the timer, to help scaffold their learning in mathematics. In addition to variables, children will also be encouraged to debug programs. They do this by going back through the program and identifying where the problem is, and then breaking this down into smaller parts to make the problem easier to solve, also known as decomposition. This type of problem solving can also be useful in other subjects such as DT, science, and most importantly mathematics. As well as the links to the core subjects, Brennan et al. Also finds a way to implement programming into the foundation subjects. He demonstrates this using the popular program known as Scratch. Children can use this Scratch to program characters to dance to specific beats. This type of programming can be used alongside learning in PE, where they perform dance routines using different movements. Scratch also gives children the opportunity to experiment with audio. For instance, children can create their own music videos with a focus still being placed upon programming loops and debugging. Obviously, this can be implemented into music lessons where the focus is on composing music. No matter what the subject the teaching of programming is implemented in, the key is to nurture children's curiosity, thus developing, consolidating, and deepening their understanding. It is important to build upon children's interests and prior experiences, as pointed out by Piaget's theory of active construction of knowledge. Therefore, as suggested by NCTL Computing Expert Group, teachers need a very solid subject knowledge on programming in order to know where to best implement it across the primary curriculum.